All right, so now we've got a complex circuit. Remember, these are just kind of parallel and series in in the same circuit. So you can't apply the rules directly to the table as a whole. You have to find that equivalent resistance or apply the rules only to little sections of it. So 2 and 3 here, 2 and 3 can use the parallel rules, whereas 1 can only use the series rule once we know more things about the other. So we have to kind of work through that. Now, remember, the first step here is to turn it into a single resistance. We want to get this down to a single circuit, plus minus, single circuit with a single equivalent resistance. Now, again, this is the equivalent or total resistance here of what these would simplify to. So to do that, I need to work from the inside out. So I'll start by combining R2 and R3 into one resistor, RA. And so that still has R1 in it, but now I have a new resistor, RA. And that's 6, and RA is not 6 or 12 ohms. I need to calculate that. So again, RA is going to be 1 over 6 plus 1 over 12, all to the -1. And when I put that in my calculator, I get 4 ohms of resistance. And so that is an equivalence of 4 ohms there. All right. And then the next step, I'm going to combine R1 and RA into RT, and that's just going to be 6 plus 4 because those are in series with each other, and for a total resistance of 10 ohms. Right. And so I can write that in the table, 10 ohms. Now I jump over to the table and start calculating the things that I can. So I see that I have 60 and 10. That means that the current flowing through that would be 6 amps. So then I take that. That's all I can do in the table so far. I can't just randomly take that through. I need to look at the circuit and think about that. So that's 6 amps coming out of the battery. But then as I follow that, I can see that that 6 amps goes through R1. So I know the current through R1 is 6 amps as well, and I can bring that down and add that. Now I know two things in a column, so 6 times 6 tells me 36 volts. So I know the volt drop across that is 36 volts. All right. Then I keep going. So I'm still thinking about the current. I know the 6 amps comes out, and then that 6 amps hits that node. So when I hit a node, I need to shift my thinking from current to voltage because I know the current splits and I just don't know how much in each direction. So when I shift to thinking about voltage, all right, I come over here, I see that I'm at 60 volts. So I'm at 60 here, 60 on this side, and then I lose 36. So that puts me down to 24, puts me down to 24 volts on this side. And 60 minus the 36 gets me to 24 volts. And then I keep kind of thinking about voltage, and I know I get down to 0 volts on this side. So by looking at that, I can see that the voltage drop across 2 and 3 each is 24 down to 0. So those are both going to be 24 volts and 24 volts. And I can finish off my table and calculating the things by saying 24 divided by 2 is, or 12 is 2 amps, and 24 divided by 6 is 4 amps. And then the final check is, do those two, do the 4 and the 2 add up to 6, and they do. So that is a good check of that one. Right. And so I did the same sort of thing on this one, just a little bit more. And again, I didn't work all the way through it because I want to keep it a little shorter. So condensed it down all the way down to 5.2. First ones I combine the R2 and R3 together to get 16. And then I combined that RA 16 and the 4 in parallel to get 3.2. And then you just add the 2 and the 3.2, the R1 and the 3.2 to get 5.2 ohms. All right. And then 10 amps comes from the V equals IR. Come back up. I can see that that flows through R1. So that's 10 amps to there. That allows me to calculate R1 voltage of 20 volts here. And then I then subtracted that from the 52 to get 32 volts the top of the parallel area, and 32 down to 0 told me that's 32 across R4, which allowed me to find 8 amps. Once I know it, 8 amps goes one way, I know the 2 amps has to go the other way out of that node. So each R2 and R3 both get 2 amps, and then I can calculate the voltage drop across R2 as 12 volts and the voltage drop across R3 as 20 volts.